Welcome to HVAC TruePrep AI Tutor, the hands-free way to stay sharp anytime, anywhere. Let's now turn our attention to a critical aspect of HVAC and refrigeration systems: the properties and safety of Freon refrigerants. When we study refrigerants, especially the Freon family, it's important to understand how their molecular structure affects their properties, as well as the safety considerations when handling them. Let's break this down into several key areas: molecular weight and boiling points, physical and operational properties, safety issues such as flammability and toxicity, and finally, compatibility with materials. Molecular weight and boiling points. One of the most fundamental chemical relationships is how substituting atoms changes molecular properties. For refrigerants, replacing hydrogen with fluorine increases molecular weight and lowers the boiling point. For example, methane has a molecular weight of 16 and a boiling point of 258.5 degrees Fahrenheit. Freon 14, by contrast, has a molecular weight of 88 and a much lower boiling point of negative 198.4 degrees Fahrenheit. Adding chlorine atoms into the molecule lowers the boiling point even further. Methylene chloride, MW85, boiling point 105.2 degrees Fahrenheit. Freon 12, molecular weight 121, boiling point negative 21.6 degrees Fahrenheit. In general, Freon compounds are known for their high density, low boiling points, low viscosity, and low surface tension. These properties make them highly effective as refrigerants. Table 1 illustrates the molecular weights and boiling points of different fluorinated products. Key properties of Freon compounds. Beyond boiling points, Freons also have unique physical properties. They are poor electrical conductors but excellent dielectrics, which makes them useful in systems requiring insulation. They have low vapor-specific heat and a low latent heat of vaporization, so performance data is often provided in manufacturer thermodynamic property tables. Table 2 lists key operational information about new refrigerants. Flammability. One advantage of Freons is that they are non-flammable and non-explosive. However, if they are mixed with flammable substances, the mixture itself may become combustible. Toxicity. Under normal handling conditions, Freons are generally considered low in toxicity. However, high exposure or deliberate misuse, such as inhalation, can pose significant risks. Table 3 outlines hazards, including toxicity and safety concerns. Skin effects. Because many refrigerants have very low boiling points, below 32 degrees Fahrenheit or 0 degrees Celsius, liquid contact can cause frostbite. Protective gloves, eye protection, and proper clothing are required. If frostbite occurs, the affected area should be warmed quickly and medical help sought immediately. Higher boiling point fluorocarbons don't freeze the skin, but they remove natural oils, leading to dryness or irritation. Rubber or plastic gloves are recommended in these cases. Oral and inhalation toxicity. Oral toxicity is usually low, but if swallowed, Freon can cause lung damage. Vomiting should never be induced. Inhalation at high concentration can affect the central nervous system. Symptoms may include intoxication, loss of coordination, unconsciousness, or even death. The proper response is immediate removal to fresh air. Importantly, adrenaline, epinephrine, must be avoided because it can worsen cardiac effects. Cardiac sensitization. At high vapor concentrations, Freon vapors sensitize the heart to adrenaline, which can trigger arrhythmias or sudden death. Again, the treatment is fresh air, prompt medical care, and avoiding epinephrine. Thermal decomposition. If Freon compounds are exposed to very high heat, they decompose into toxic halogen acids such as HCl, HF, or HBr. These byproducts are dangerous, and if decomposition is detected, the area must be evacuated and ventilated immediately. Compatibility with materials. Another practical concern is how Freon interacts with different construction materials. Metals. Freons are generally safe with common metals such as steel, iron, brass, copper, aluminum, tin, and lead. However, at high temperatures, some metals act as catalysts and accelerate decomposition. The order of least reactive to most reactive includes Inconel, stainless steel, nickel, 1340 steel, aluminum, copper, bronze, brass, and silver. Avoid using magnesium alloys with more than 2% magnesium. Zinc, especially with Freon 113, and highly reactive powdered metals such as aluminum, magnesium, sodium, potassium, or barium. Plastics. Compatibility varies and must always be tested. Suitable. Teflon, low diffusion. Orlon, nylon, except at high temps. Cast lucite, epoxy resins, Delrin, cellulose acetate/nitrate. Caution, limited use. Polychlorotrifluoroethylene, polyethylene, vinyl, phenolic resins. Generally unsuitable. Polystyrene and extruded lucite. Download HVAC TruePrep AI Tutor for more free lessons and practice tests. Now that you've learned the key concepts, let's check your understanding with a few review questions. Question 1. What is the molecular weight of methane? A. 88, B. 16, C. 121, D. 85. The correct answer is 16. Explanation. Methane has a molecular weight of 1616. In refrigerant studies, it is often used as a baseline example to illustrate how replacing hydrogen atoms with fluorine increases the molecular weight and lowers the boiling point. This makes it an excellent reference point when comparing to heavier compounds like Freon 14. Question 2. What is the boiling point of Freon 14 in degrees Fahrenheit? A. minus 21.6, B. minus 198.4, C. 105.2, D. 258.5. The correct answer is minus 198.4. Explanation. Freon 14 has a boiling point of minus 198.4 degrees Fahrenheit, which makes it useful in ultra-low temperature and cryogenic applications. This extremely low boiling point results from replacing hydrogen atoms with fluorine, which increases the molecular weight and shifts the liquid-to-gas transition to much colder conditions. Because of this property, Freon 14 is chosen for specialized refrigeration systems that must operate at extremely cold temperatures. Question 3. Which Freon compound has a molecular weight of 121? A. Freon 12, B. Freon 22, C. Freon 11, D. Freon 14. The correct answer is Freon 12. Explanation. Freon 12 has a molecular weight of 121 and a boiling point of negative 21.6 degrees Fahrenheit. It was one of the most widely used refrigerants in household refrigeration and air conditioning systems. Its popularity came from its relatively low boiling point, chemical stability, and non-flammability. However, it has been phased out in many countries due to environmental concerns, especially ozone depletion. Smash your test goals with AI. Search HVAC TruePrep AI Tutor on App Store or Google Play and level up today. Or, if you want a more convenient option, simply click the link in the description below to download the app. Don't forget to like, share, and subscribe to the channel so you won't miss out on the latest tutorials and updates about TruePrep AI. Thank you for watching.